Welcome to our lesson on interpreting standard deviation. So, when the standard deviation is small, the group is said to be homogeneous. In other words, all scores are close to the mean. The opposite is true for a larger standard deviation. So let's get into an example. Let's say the table below shows the average scores earned by two batsmen and their standard deviations. Which batsman would be better to hire? So looking at our data here, both of them have the same average of 50, but the standard deviation for the first batsman is 2.3 and the standard deviation for the second batsman is 10.5. Since both of them have the same average, we need to consider their standard deviations a little bit more closely. Batsman 1 has a much smaller standard deviation and hence is more consistent. Batsman 2 would vary wildly. Hence, batsman 1 would be the better choice. The standard deviation is also an integral part of the normal distribution. What is the normal distribution? Well, it is the distribution that governs the height of a population, the weight, and even the shoe size. What do I mean by that? If you look at the height of a population, you'll find that the majority of people are somewhere near the middle or the average. And the further you go out from that average, whether being less than the average or more than average, there's less and less people who fit that data. Meaning that the majority of people are an average height. And there is less persons who are shorter than the average height the further you go away from the average height on the shorter side. There are very few people who are very short. And the same thing goes on the other side. There are less and less people who get taller than the average and very few who are very tall. According to the normal distribution, in a normally distributed population, 68% of the population lies within one standard deviation of the mean. So on both sides, to the left and to the right, below and above the average, 68%, 34% because it's symmetrical. And then within two standard deviations, 95%. And within three standard deviations, 99.7%. So almost 100% of the people lie within three standard deviations on either side of the mean. Next, we need to look at the z-score. It tells you how many standard deviations from the mean your score is. And it is calculated using the formula z equals x minus x bar over sigma, where x is the particular score you're looking at, x bar is the average, and sigma is the symbol we use for standard deviation. So let's get into an example now. The average height of the male teachers at SCA is 5 feet 10 inches with a standard deviation of 2 inches. Draw a bell curve to represent this information. The average height of the female teachers at SCA is 5 feet 4 inches with a standard deviation of 3 inches. Draw a bell curve to represent this information. And finally, if Mr. Matt, some fictional person, is 6 feet 1 inches tall and Mrs. English, another fictional person, is 5 feet 11 inches tall, who is actually taller when compared to other people of the same gender? So first off, the males. The average was 5 feet 10 inches as stated. Their standard deviation was 2 inches. So that means that one standard deviation above 5 feet 10 inches would be 5 feet 12 inches. Or in other words, 6 feet 0 inches. Another 2 above that would be 6 feet 2 inches. And another 2 above that would be 6 feet 4 inches. Below the average of 5 feet 10 inches, you would go down by 2 inches as well. So you would have 5 feet 8 inches, one standard deviation below, 5 feet 6 inches below that, and 5 feet 4 inches below that. So as you can see there, within one standard deviation, there is 68% of the population. In other words, from 5 feet 8 inches up to 6 feet 10 inches is 68% of the population. 95% of the population goes from 5 feet 6 inches up to 6 feet 2 inches. And the 99.7% of the population lies within 5 feet 4 inches up to 6 feet 4 inches. Let's look at the females. So their average was 5 feet 4 inches and their standard deviation was 3 inches. So we add 3 inches to that 5 feet 4 inches, we get 5 feet 7 inches, then 5 feet 10 inches, and finally 6 feet 1 inch, 3 standard deviations above. Below, we subtract 3 inches each time, so we get 5 feet 1 inch, 4 feet 10 inches, and 4 feet 7 inches. So, finally, we are told that Mr. Matt, he has a height of 6 feet 1 inch. What would be his z-score? So, his z-score is 6 feet 1 inch minus the average, which is 5 feet 10 inches, divided by the standard deviation, which is 2 inches. So 3 inches divided by 2 inches gives us a z-score of 1.50. For Mrs. English, her height was 5 feet 11 inches. If we subtract the average of the women from her height and divide it by their standard deviation, which was 3, we get 2.33 to 2 decimal places. Because Mrs. English's z-score was greater than Mr. Matt's z-score, then she is further away from her average. Meaning, in other words, she is taller compared to the people of her gender. Even though, absolutely, Mr. Matt happens to be taller, absolutely taller, compared to the rest of his gender, he isn't that much taller than Mrs. English compared to the rest of her gender. And with that, we come to the end of this lesson. See you in class.